well, or new tech inventors, anyone starting 3D printing needs to know a little bit about 3D printers. To be able to print something on these printers, you have to have a 3D image that has been converted into a file that this printer can read. It's a long set of instructions. I think I had a video one time where I showed one of the parts where it had several thousand lines of code, and each line of code was actual positions, like a GPS system, telling each one of these servos how many increments to move to find that next position and move the head to it. And then the next line of code moves the head another notch. And that's how the whole print process works. And not only does it tell that head how to keep its position, but it regulates the speed that this filament is fed through the nozzle. And it regulates the temperature in the nozzle. And it regulates the temperature of the bed. And a lot of other variables. Everything having to do with this printer, making this part, is in that code. It's called a G-code file. Now, to get a G-code file, you have to first get a 3D CAD image. You have to draw or purchase a 3D CAD image that has been drawn by someone and saved to an STL file. So you have a 3D image of this part in an STL file. And then once you have that, then you can load that STL file with that 3D image into another software called a slicer. And that slicer, normally when you purchase any of these printers, they'll come with a little chip, a micro SD chip. And on that chip, you put it in your computer, and there'll be a program there called Cura, and it's usually modified by the manufacturer of the printer so that it says King Rune on it, for example, but it's a modified version of Cura specifically for this printer, set up for it, and it makes it a little easier to use that software to set the settings for your printer. And then once you set up the temperatures and stuff that you want, which is based on your filament back here, then you can actually slice that image using those settings, and it will generate that G-code file we were talking about. Then you take the micro SD card, and all of these printers have a little micro SD card that goes in. You take that, put it in your computer, copy or save the sliced G-code file to the micro SD card. Then you come back and you put it in your printer. And then when you turn your printer on, there'll be some settings that you'll go through, preheating the nozzle and preheating the bed and loading the filament. We'll go through all that later also. You'll select that G-code file from a menu of files that are on that chip, and when you select it to print, then it will automatically load that G-code file into the printer, and once it's preheated, it will start printing, and when it's finished, you'll have your part. That's basically how everything works. To summarize, you get your printer, your PLA filament, you get an STL file from a 3D CAD software, or you purchase an STL file from Thingiverse or someplace on the internet where they sell or give them away for free, and then you take that STL file and load it into your slicer program, Cura program. And if you don't want to use the one that comes to the printer, you can download Cura. It's free. You can go out on the internet and download the Cura software and get a current version of it. It's just that when you get that one, it's a little more complex, has a lot more settings and everything. So starting out, you might want to just use the one that comes with this, which has only a few options, and everything else is already preset pretty much for this printer. And then, once you slice that and put that chip in here and set the printer to run, it's going to print. So it's a pretty simple process. Now, backing up a little bit, getting that STL file, you can make your own design. You can do your own 3D CAD design. I've done a few videos, a couple of them up here, as a matter of fact, that showed actually designing some parts using the CAD software and how I designed some simple parts and then saved them to an STL file, which actually creates a three-dimensional file in an STL format. And once you have that, then you run it through your slicer and generate the G-code file and get it in the printer. But doing the CAD, you have to, it takes a little bit of trial and error. Unless you've had some experience with some type of a CAD system, it may take a little bit of time to sit down and follow the instructions or tutorials. And for most CAD systems, you can find tutorials online, on YouTube. A lot of people have done tutorials on the CAD software. And you can learn that CAD software and learn how to use it. Like with this part here, it prints in that position. So when I made that part, I had to start out with a square. Actually, a little more of a rectangle here on the bottom. And then, once I had that square, then I knew I was going to need 3 holes for power connectors. Knew I needed a rectangular hole for a snap-in switch. Knew I needed 2 slots here with these holes. So I was going to have those things. So what I did, I actually drew that square, drew the holes in these slots, and then I drew these slots here. Then I allowed that to print and start coming up until it got to about 2 or 3 millimeters thickness. And then at that point, then I changed, because you can see I've got a cavity in here. But this part of the block continues up, and it's solid to some degree. It has an infill, which is like a honeycomb core in here. And you can see as it comes up, you create this box, and then I had to put holes in here that ran down for these parts to actually fit in there. And that's how the helping hand works. It's a multi-tool device that has electrical power to power different tools and so forth, and it has various accessories that can be put in. And this will hold 3 different accessories of different types at a time. There had to be some consistency to to make these parts and then make the other parts that lock in and fit inside of them. And then these have to be pretty accurate for the parts to be able to snap into those positions. And then you have to have a mounting on the back. Now this is an old version. It's not one of the current ones. I think I probably had about 20 versions of this part before I came to the final version that we're using today. If you look at this, you can see that this bracket that this hinges on, and it goes on to different mountings, but it hinges so that these tools and stuff can be on a boom and be put in different positions. But when you have a lot of weight and people are moving this around by hand and they don't unlock the boom very well and they put stress on, this was pretty thin here and it would break. So it took quite a bit to break it, but it would break nevertheless. So now if you look at a current version, you'll find that this is still this thickness here, but then it flares out considerably. And it's a lot heftier, and I haven't had one break since then. And we put that through some rigorous testing. These parts here go on the end of a steel rod that's used to mount this to a table mount. And then of course a bolt goes through here, which allows that to pivot. These parts have to be really strong too. So actually some of these parts are printed with PETG filament, which is a stronger filament. So that's a little bit that goes into the CAD drawing and being able to draw these parts. But even when you draw them, like I said, you may have 20 different versions. Because each time you draw them, you try out different things. And when you make these parts, you might find out that, okay, I made this part, but this part may have come out where it doesn't allow it to go all the way down in there. And you have to remake it. Or this, something on this part doesn't line up, or the hole's not large enough in here for this pin. So a lot of trial and error in coming up with a finished design. This switch may be a little loose in there. You may have to try a couple different times. And then, to complicate things even more, once you get into production, you have to really fine-tune the printing of these parts depending on the printers that you're using, depending on the filaments, the nozzle size, a lot of variables. So that's one reason I'm printing a prototype down there on a part that we've had for quite a while, that I found it has, in some extreme cases, it can crack. And it's just a small sleeve, actually, that goes over the other part of this, where it mounts, to give additional strength and to hold it in positions. So we're actually making that part about 40% thicker on the shell. And when we print it, we'll be printing it with a denser infill to add strength. And I think that will take care and solve our problem. It's going to be difficult for me to edit this video that I'm taking here and make a good educational video out of it. I do everything off script, so I don't have any guidelines or things to go by. I just know that I want to talk about something, so I sit down and take off in a direction and get distracted and go in different ways and sometimes deviate from the original plan. I've tried to correct a lot of that in the editing, and stick to the key points. But one thing that will help me more than anything else is to get some feedback, some suggestions on things that I need to talk about. You guys that have been out there doing this longer than I have, you know a lot more than I do. You could probably have some good suggestions for me that would help someone getting started. Because even though we're a little bit farther down the road ourselves, we all need help from time to time. When we think back to when we first started, if you're anything like me, I could have used a lot of help. I was a little stubborn, and I tried to do everything on my own and learn everything myself, and I learned the hard way, but nevertheless I learned. And then as I went farther along, I started finding out that there are a lot of people out there doing YouTube videos on some of this stuff, and I started going out and looking at some of the YouTube videos, especially with Autodesk 123D Design that I was using. I was trying to make threaded parts, like this part right here has 3 ports here that have a 1/4 inch thread in them. And when I first made this part, I just made it with holes there, and I took a tap, 1/4 inch, 18 I think, thread tap, and tapped the holes. Of course, when you're tapping the holes, it puts a lot of stress on the part, and the part would crack here sometimes. So I knew then I needed a stronger part, so I made a stronger part. But I thought, heck, having tapped these holes out by hand is a problem. Why can't I print those threads? And that's when I went online and found out how to, using that 123D Design software, how to make threads and incorporate them into the drawing. And I did, and they work great. Nowadays, with some of the newer 3D CAD softwares out there, Fusion 360s and others, a lot of these tasks and things are a lot easier. They've made them easier in the CAD software, but there's still things that I found that I could get help on YouTube understanding different things. Even the filaments. When I first heard about PETG, I didn't know what the difference between PETG and PLA was. I knew that I could buy the PETG. One time I was buying some black filament, and I found out I could buy some black PETG for a little bit less than what PLA costs. So I figured, well, what's the difference? Well, it's got to print at a higher temperature. I found that out, and I started checking, finding out what the different strengths were and stuff. And by going out and Googling it, and in addition to that, finding YouTube videos that talk about the differences and the strength and performance and so forth of the different filaments, it was very helpful. And that was one of the reasons why I decided to do these videos. I figured, well, as I learned stuff, maybe I can pass it along in the videos and help somebody else. So that's what we're trying to do here. So if you have any suggestions, please let me know, and I'll see if I can't incorporate those into some of these videos that I do. And also, if someone out there is just getting started and they have questions, things that I kind of skirted around, or maybe I didn't answer some things, ask those questions. It doesn't matter how crazy they are. When I first started, and this is the honest truth, and got my first printer, and I knew so little about 3D printing that I found out that you have to have an STL file. So I figured, okay, you have to have an STL file to print something. Or I thought I could put that STL file on the chip and put it in the printer and print from it. I found out very quickly that no, you've got to slice that STL file and create a G-code file. And the way I actually found out about that, I created the STL file, but then I realized that the sample files that came with that printer were G-code files. And I thought, well, they print fine, they're G-code files, but the STL file doesn't print. So, being stubborn, like I said, I'm trying to do this all on my own. I don't ask for advice or go out and look for answers. It was then that I started reading the instructions that came with the printer and realized that I had to load that slicer Cura off of the chip that came with the printer onto my computer. Once I loaded that, I could load the STL file into that slicer, then transfer it to a chip as a G-code file, and bam, it prints. So I know there are a lot of questions, and some of this stuff may not be real clear. I don't want anyone to get frustrated. If you've got a 3D printer and you've tried to print, and you've had problems, and you're getting frustrated and thinking about giving up, write a comment. Send me a comment. Tell me what's going on and what kind of problems you're having. And I guarantee you I can get an answer for you. If I can't answer it, I'll get somebody else that watches these videos. And I've got a lot of good friends out there now that have been doing this for years, a lot more years than I have, that are a lot smarter than I am. And they're always willing to help. They're always willing to help me, and I'm sure that they'll answer any questions you have if I pass them along. That's what this video is about. Be sure to subscribe, and that way we can stay in touch and you can get these videos, and hopefully they'll help you along your way. Thank you for watching, and happy printing. So until the next time, happy printing from New Tech Inventors.